Hello and welcome to Intersil. I'm Eric Pitana, Senior Product Marketing Manager in the Industrial Power Group, and today I'd like to introduce to you not one but two new devices, part of Intersil's family of fully encapsulated power module, the ISL8202M and ISL8205M. When compared to a traditional implementation of a point of load, a lot of precautions have to be taken into selecting the controller, the FETs, the inductor, the drivers, in order to meet certain performance and size criteria for the point of load being designed. The ISL8202M and 8205M integrate all those components in a small 4.5mm by 7.5mm package, reducing the guesswork related to developing a point of load solution. Now, immediately, benefits can come to mind. The first one is the compactness of the overall solution, increasing to a higher power density reachable on a PCB board. The second one is the ease of design and use. Only a few components have to be selected to make this part operate. The performance is very predictable because now all the solution, all the power module has been characterized and in essence are less sensitive to component variation and aging. Finally, with a height of 1.85mm, this power module can easily be mounted on the backside of a PCB board, freeing up valuable space for topside mounted components. For this exercise and this video, we're going to be using an ISL8205M evaluation board sitting here, and we're going to review some of the specific features and characteristics of this solution. So let's turn it on. Here on the scope, we have three informations. The input voltage, currently sitting at around 5 volts, the output voltage, 1.2 volts, and the switching node underneath. This device supports anywhere from 2.6 volt to 5.5 volts input voltage range. The output voltage range can be as low as 0.6 volts. The evaluation board, as a matter of fact, provides you with an easy setting that selects some of the most common output voltages in use in the electronic industry. The output current will be set through a classical chroma load. In this case, we are actually currently running at 5 amps output, so the maximum output current available for the ISL8202 and 8205M. Some of the specific features of the part makes it very suitable for battery-operated equipment, one of which being the capability of the ISL8205M to be configured to support a light load boosted efficiency mode. It is selectable because some designs prefer to stay with a constant frequency, whereas others, battery-operated, typically may require to use a variable frequency in order to boost the light load efficiency, meaning anywhere below 700 milliamps of output current. We see here that we are currently running at 3 amps of output current. I'm going to switch down to 50 milliamps. And one thing that we're observing immediately is that our switching node operates by burst pulses. This is also known as pulse skipping or burst mode in the literature. I can go from one to the other, and we can see that the part will react immediately to a light load condition by halting essentially the switching mode, turning off the bottom FET, and essentially allowing the output cap and the output to discharge fully into the load. Another specific feature of the ISL8205M, specifically targeted to the battery operation, is the capability of supporting a 100% duty cycle, also called LDO mode. In this case, the power module is capable of adjusting its output duty cycle in case the input voltage reaches very close to the output voltage selected. This is typical of a battery voltage decaying over time between charges. In this case, we've set the output voltage to 3.3 volt. We're still running at 5 volt input, and I'm going to slowly take down the input voltage to reach closer to that 3.3 volt desired output. One thing that we can observe is that at a certain point, my switching node has stopped switching, essentially turning on the top FET constantly, and the difference between the input and the output voltage remains constant, or about 200 millivolts in this case. As I keep going down, this delta is going to be maintained for as long as possible until eventually the part input voltage collapses and the part turns off because we've hit the under voltage lockup situation. Please visit us online at www.intersil.com. Thank you.